And so IPython has a fairly elaborate and somewhat complex configuration system, but it's very powerful, and IPython is a power user tool, so understanding how this works is useful and is part of the point of this tutorial. So if you open the Configuring IPython notebook, you can follow along with me. I'm going to go relatively quickly. So if you type IPython-H, IPython gives you help information. This is everything we print. And a lot of the flags that are available to start things and whatnot are there. But it's important to know that in addition to typing -H, you can type --help all, which will often print, which will print even more in-depth information. So -help, the basic one, prints some help information, but -help all prints a lot more. So this is what you get with help, which appears to be quite a bit. But if you say --help all, there's even more. And the difference is that now it prints, in addition to what was there early, it actually prints all of this information about how the actual names of every parameter that is configurable inside of all of the IPython applications is named. So very often, if you want to find out how to do something, you can simply type help all and pipe that to grep and look roughly for something that you're thinking about. And that may be enough to tell you, or load it in less and look for word patterns that you're thinking of, and that may be sufficient. So often, rather than asking on the list or bugging or trying to dig into documentation, this is the quickest way to figure something out. A common question is, well, how do I configure whether at the shell IPython asks me for confirmation for exit or not? Well, if you grep for the word exit, you'll find that, oh, there is a -- no confirm. Oh, this is because grep on my system tries to syntax highlight output. And so I'm getting color codes from the terminal. But there's a no confirm exit flag. And so now you know that if you want IPython to not ask you for exit confirmation, this is the flag you need to pass. But it also says that there's a terminal interactive shell confirm exit flag that you can set permanently. So there are a bunch of options that you can pass on the command line, but they also have this long form of key value pairs. And this long form corresponds to the attributes in the actual objects that are set permanently. And these can be stored in files. So the way these, the shorthand command line flags that you use to configure how you like it to start are actually only shorthands into a bigger and kind of deeper system that uses class attributes for everything. And so the way we have a generic base class of something called a configurable, and you set values in these base classes, and those define how everything behaves. And so a lot of every big IPython object, the notebook machinery, the terminal machinery, all of them have a long list of these configurable things that you can introspect, and they are all stored in special directories called profiles. So you can make a new profile by typing IPython profile create. You can create profiles with a new name, IPython profile create new profile. That will make a new profile. By default, I already had one, but this will make a new profile called new profile, and it says where it put it. And so the idea of these profiles is that they are locations where you can define all of the configuration related to a specific project, to a specific task that you want to do, and you can shove all that in. You can keep multiple profiles that have perhaps conflicting stuff that you don't want loaded at the same time. That information can be kept in separate profiles, okay? And you can get the location of your profile. This, in this case, is the currently active profile. I am running this notebook under the SciPy profile that I made to make sure that it was empty and it didn't have anything that could confuse you guys from my whatever default configurations I have. And this is the kind of information that is in the profile directory. We keep security files, we keep log files, we keep your history SQLite database, and we keep the config, all of the config files that let you tweak and customize. So if you find a profile, you can go then and edit these config files that are automatically created. And in those files, you can set all of these configuration attributes. Now, you can, and we don't, this is what these files look like. I'm going to show you one of these config files. This is the default one. So the way, what they look like is a commented out set of all of these key value pairs with the comments here that you would get from the help file. And the idea, they're fully commented out because all of these default values are internally preloaded, but we give you the information there so you can uncomment and change values for the things you want to change. So the idea is if you don't do anything to these files, then the system loads its internal defaults, but if anything you change will get loaded. In this case, for example, I changed the color scheme so that it would show up by default on light backgrounds, which I know projects better on and records better on projectors. So I made that change. It's the one thing that I changed in this profile from the default color scheme. On Linux, the default color scheme is Linux, which is kind of tailored for dark terminals, but that doesn't display very well. Now, there are a few aspects of the config system that you can control at runtime. For example, if you type config, the system will actually find which objects are available for configuration, and some of these things can be modified at runtime. So for example, matplotlib has by default the matplotlib inline backend has by default PNG for figures. Matplotlib is capable of computing figures either in PNG or in SVG form. By default, we send PNG. The reason why that appears, even though that may sound like it's not a good idea, is because SVGs in Matplotlib, in certain edge cases, the quality does go a little bit down. And B, if you have lots and lots of data, they get arbitrarily large and they can get extraordinarily big. And when that happens, you slow the browser to a crawl. Whereas a PNG, no matter what is in it, a PNG is a PNG, it's the size of the image, whatever it is. It's kind of a known bounded quantity. But if you want to change that, you can say, oh, config inline backend, and then I want to say the figure format by default is, if I want SVG. So let me show you that if I say, if here I say plot, this is a PNG image, if I resize it, you see that it's pixelated because it's a PNG image. If I now say, change this to be by default SVG, and now I redo this plot. Now I get an SVG, a native SVG image. So can you pass me that tea? Just a little liquid.
So when I did that one without the dot figure format, something gave me an error.
When you just typed this, had you loaded PyLab before? How do you run this line that was above? If you hadn't run that line, the inline backend object doesn't exist yet. So you can't configure it because it doesn't exist. Okay? All right. So all of the things that, all of these things can be set persistently in these config files. So the idea is there's a few things that you may want to change at runtime. All of it can be written persistently. And one of the typical things that you end up wanting to do persistently is defining your own magic commands. So let's have a very quick look at how do you define a very simple magic. Obviously, here I'm going to be doing it live in the notebook. You could put this into one of the startup files in your profile directory. In the profile directory, if you create within the profile a subdirectory called startup, anything you shove in there gets executed at startup time. So you can basically put in there scripts that preload anything that you want to always have for that profile. And now, let's imagine that we want to have a magic called sleep magic. The way to create a line magic is by simply writing a function that takes a line as its input argument. This will be the body of the line that it is called with, and then that function can do whatever it wants with that code. In this case, it takes that line, it assumes that that line is a number, so it converts it into a float. It'll always get the line as a string because the syntax is arbitrary text. So we pass the line as a string, and then it sleeps for that amount of time. And this is how we actually turn this function into a magic. We call on the IPython object, we call the register magic function call, which says register this function as a line magic called sleep. So once I do this, now I can type %sleep2, and IPython will sleep for 2 seconds. I can type %sleep 1.1, and it'll sleep, and you can see the kernel busy indicator for that amount of time. Sleep 10, and it keeps on sleeping. If I interrupt it, I'll get as a traceback the traceback in that magic, right? Plus whatever the internal bits and pieces of IPython itself that we're making that function call, right? So the define magic obviously explains to you how you register a line magic. You can also register a cell magic, and we have, in our documentation, we have sort of in-depth information on how you can create more complicated magics. This is a very simple magic, which is just a function. If you want to create some of our magics, such as the ones that interface with R and with Octave and with Cython, or enormously complicated pieces of code, there we actually have an object that you can inherit from that provides a lot of support machinery for basically keeping state and keeping handles on existing objects. For example, the R1 has to keep a handle on a running R interpreter and things of that nature. So this is the very simplest one. The documentation has examples and our own code. If you look at our own magics, right, you can see how much more complicated ones are implemented. But this gives you an idea of how to extend the system on your own. In the interest of time, I'm going to skip the exercise of defining your own magic, but I did want to show you how. So in your profile directory, there is a startup subdirectory that is always created by default. That startup subdirectory has a little README that explains you how to use it. And basically, it's simply anything you put in there is in lexicographic order executed by IPython on startup. So if you want to keep a bunch of things of Python code that you want to load on startup, just shove it in there as a bunch of Python files. You can order them if you want. If not, they just get loaded in. I mean, you can order them with a classical trick of putting numbers in front of them, but if you don't do that, whatever files are found there will get executed. So it's an easy way of saying, whenever I start, I want the following things always preloaded, okay? So this is a quick overview of the config system. It's a little bit of a dry topic, which is why I don't want to spend too much time on it, but it's also an important topic, so at least we wanted to cover it. Okay? Yes, question?
How does that stuff get exported from the notebook file? So you're sharing with someone.
Not at all. Not at all. Not at all. That information is currently not captured at all in the context of sort of a fully replicable environment. Obviously, you would want to, if there's a lot of customizations in there attached to a project, what you want to do is you want to ship the profile together with the notebooks, basically. So that because the profile may actually constitute the preloading of the environment for that project, right? So so you might want to ship it to your users along with. But right now, an NBViewer treats notebooks kind of one at a time, so there is really no support at the project level.
Is there an elegant way to combine those two, or can you drop that profile in there?
No, right now there's no elegant way. All of the profile directories are kept as subdirectories of your main.ipython directory. But one thing that we are thinking hard about is maybe also supporting the notion of per directory profiles, so that at least if you're version controlling together, basically your notebooks and the profile, but you keep the profile right there, right? Then if you ship that repository to someone else, when they open it, that profile came along with the notebooks, and when you start, it'll get recognized. So I think we're going to end up doing something along those lines. We haven't worked out the details, but for reasons of being able to ship a complete environment that replicates a computation or project, having those closer together is an important consideration, and we're seeing clearly that we need to do that, something in that direction. We haven't implemented anything quite yet, but we'd be happy to chat about kind of good strategies. Yes, Aaron.
Real quickly, if you want to define a magic that has options, do you just use argparse to do that? Or?
Well, but that's where our magic object provides already methods for option parsing and all that.
Oh, okay.
So if instead of doing it as a single, once you go beyond the trivial ones, I would encourage you to inherit from our base Magics object because it already has methods handling arguments. It does the right thing in how to escape a line to split it in something that looks like what the system does with sys.argv and all of that mess. We do it for you in the base object. Any other questions? Okay, so let me switch. At least I want to talk a little bit about a topic that a few people asked about before we do the parallel demo. A topic that a few of you asked about in the chat room, and which we had said was in there. So I'm going to go to terminal usage, but I'm going to skip some of the basics. Well, I'm going to quickly go through a couple of things here. First of all, okay, let me get out of. So let's say that I have a file called script.py. In the notebook, if you have this little chunk of code, you would just basically put that in a cell. But if you're in a terminal-only environment, and you have, whoops, let me do this with my profile. That gives better color schemes for this and better. So if I have that file that has these variables, right? And in the notebook, at the terminal, I don't have cells. I don't have nice multi-line editing. The classical workflow is you have a file open in a text editor, and you're working here. But we have a magic called %run or run. And run simply executes that code as a script. But in addition to executing that code, then any variable that is defined in the script is now available to you for working interactively. So before we had the notebook, the workflow, the classic workflow was text editor, terminal, edit the scripts in the text editor, and go to the terminal and type run and sort of iterate back and forth. And even though the notebook replaces many, many things, sometimes this is still a viable tool. You may be logged into a remote server. You may have an existing script that you simply want to quickly run an existing script and play with the data that it produces. And so it's important to know that in the terminal environment, the %run command will be your biggest friend. Obviously, you can also use it in the notebook. There's nothing that prevents you from doing that. But it's more commonly used in the terminal, okay? So the question was, the comment was particularly when you run it with -d. So what was this about? Well, if I ask %run ? I get information about all the things that %run does. And run takes a number of interesting flags. For example, it takes a flag -t, and it'll report timing information. So if I do run -t, it runs the code and then reports how long did it take to run. And it also takes a flash called -d, which will start the script inside of the interactive Python debugger, actually the IPython enhanced version of the debugger. And so now, and you have a breakpoint set at the first line of the script automatically. So now you can begin saying next line, next line, next line, next line, next, and now it finished and quit. So if you want to execute code under the control of the interactive debugger, this is what you want to do. And right now, the notebook does not allow you to run this. So if I try run -d in the notebook, I get an error, and I said standard in not implemented error, because the problem is in the notebook, in this version of the notebook, we didn't have control for interactive management of the sub-interpreter for the debugger. Now this has been fixed in master. Master now has interactive debugging, but 0.13.2, which is the one that was released a few months ago, doesn't. So for this kind of thing, you still want to do it in the terminal. And that stuff is tricky enough to do that in the notebook, even though we've added it, it's still a little brittle. So really robust, low-level keyboard control is always going to be better on a real terminal. And so there's still room for that.
I mean, I will say that this is the best way that I know of to debug, a complex Python program that you have.
Yes.
I'm actually not aware of any that are even close, really.
Well, I want to show another side of the same tool, which is one side of this is run -d, which is run with a breakpoint set up in advance. And you can actually, if you see, the -d flag takes an optional breakpoint line number. So you can either let it set up breakpoint automatically at the beginning, or you can say, I want to run this and with a breakpoint in line 51, for example, if you want to skip some stuff at the beginning. So your comment was that this is a very useful tool, and I agree. But the tool can be used in two different ways. The Python debugger, interestingly enough, can be used in two different ways. You can use it in what can be thought of as a forward mode, which is this mode, where you're running code forward with the interactive debugger. But you can also use it in what's called a postmortem mode, where you run the debugger against the code that has crashed and whose stack is preserved in memory. So at that point, you cannot execute the code forward any further, but you can introspect the stack back. And I find that mode to be extraordinarily useful. And so I want to show you guys how that works. So let me make a file called error, which is a file that makes that call that produces a 1/0 error that we saw before. So if I run it, I get my 1/0, and here's all the frames in the stack. Let me show you what happens in here in the terminal if I run this error script. And now I say %debug. If I say %debug, after an error occurred at any time, it'll take me back into the last copy of the stack that is alive, and it'll let me, now the code isn't running anymore, but now I can see what is the x variable. Oh, x was equal to 1. I can go up in the stack one frame. Oh, what is the function f? It's this function. Let me go again up in the stack. Let me go back down in the stack. I can print variables. I can evaluate expressions. Obviously, in this case, the error is trivial. It's kind of an off by one type error. But you can imagine this idea of moving up and down the stack, printing variables, printing sub-expressions. If you have a bug that is caused 3 levels up in the stack by some complicated expression that created an error, with this way, you can go back up, start evaluating sub-expressions on, this bit of this big nasty expression, this little bit had an off by one error, and that's what's causing the traceback. And you don't have to add any print statements. You just go up, you zoom into the stack frame that you need, and you evaluate the quantities that you require. So %debug is extraordinarily important and useful, and in 0.13.2 is only available in the Qt console and the terminal console, not in the web notebook. In master, it has been added to the web notebook. So the same capability will be available in the notebook once we release 1.0, or if you like living a little dangerously and you're happy working off of master. Okay? So these are, again, two ways of using the debugger. In forward mode with run-d, and in postmortem mode with %debug. Okay, so that is one aspect of, a very important aspect and kind of probably the key thing of using the terminal. I also wanted to mention that we do have, and this is typically used in the terminal, even though I can activate it here, we do have support for integrating with GUI event toolkits. And so if you type %GUI and you pass it an argument, then we integrate the event loop of IPython with the event loop of the GUI toolkit. And what that lets you do is run code of this nature. Where did it go? If I define a very simple Qt application that simply has a button called close, now I can write code that uses Qt, and with one particular caveat, which is that I start the event loop in a special way, I can get a window, a Qt window, and my IPython kernel remains responsive. I can keep running code, but my window is also active. In this case, I can close it and it'll close down. The point is now I'm running code from within my Python kernel, and yet my GUI windows are completely alive and responsive. And this is the kind of machinery that we use to provide support for matplotlib, for interactive plotting in matplotlib, without blocking the terminal. Okay? And so the basic idea is you enable the support by calling this GUI magic, and then when you start your application, you don't start it, you do have to start it with our event loop hooks, but it's otherwise an unmodified Qt application, so you don't have to modify your code very heavily, okay? And now, tying those two together, so there's one more piece that I want to talk about here, and then we'll tie it with at least one quick example of GUI support. IPython, as we've said before, is an embeddable tool. So you can actually embed IPython into your own code, and you can do that at multiple levels. The simplest level of embedding is simply embedding it in a terminal program. You have a Python script that you run in a terminal and prints stuff. And you're kind of confused, and you would like to get the capabilities of IPython deep in the middle of your code somewhere. You say, wouldn't it be nice if right here in this piece of my code I had IPython? all what you need to do is call from IPython import embed. And when this was contributed by Andrei Certek, who's here, we used to have this code with an uglier API, and he simplified it into, I just want to call one thing, embed. And so when you embed it, you actually can call it with no arguments and it works. But if typically you want to make some kind of print statement of like, where am I in my code? So you can pass it a little header that says, where are you? So if I write this code out as a script, simple embed.py, and let me get out of here. So I have the script simple embed.py, and let me just run it as a Python script. This is a simple Python script that's all it does, right? If I run that, when it arrives at the first time thing, it gives me an IPython prompt. And this is a real IPython prompt. I can say A was 10, B should be 20, right? C doesn't exist yet. C is defined below here, so C doesn't exist yet. I can say pylab. I can say pylab Q2, and I can load plotting support, right? So right in there, you can say, oh, wait a minute, I'm wondering what's going on here. I need to grab this variable, load a GUI toolkit, and visualize it. But you don't want to add that to your normal code. You can do that interactively. So it basically gives you an interactive probe with all of the IPython machinery that you can deploy with one function call anywhere within your code. And when you exit this, your code continues executing. And in this case, it reaches the second call to embed. Right now, C has been defined, and so on and so forth. And when you close it, it just continues. In this case, the code just finishes, and that's it. So you can deploy this anywhere in your code. The embed call is the simplest one. This code has actually machinery for deploying it persistently, for actually turning it off. If you say, okay, it's been coming up every time I iterate in the loop, but now I know what's going on. I want this thing to sort of go dead, so it doesn't keep coming back up. We have a more sophisticated API, but the very basic function call is that one. So this is embedding just the IPython engine in any terminal-based application.
And it's modifying the namespace for the runtime. It's modifying the runtime namespace, right? Not some. If I change the value of X or whatever, it affects.
So let's test that. So A was 10. If I say A is 100 now, what happens when I exit? A is now 100 because I am running in that namespace. Okay? Does that make sense to everyone? The question was whether I could actually modify the namespace. Now, we don't have a ton of time, but there's a directory called kernel embedding that shows you how you can do something quite a bit more sophisticated, which is embedding not just in a terminal script, but embedding the network-enabled IPython kernel service inside of any application that you want. So here we have two examples. One is a Qt application and one is a WX application, both of which embed an IPython kernel. So if I run this script, this Qt app script, what it does, and let me briefly show you that code. This Qt app script is a Qt application that creates a window with a bunch of widgets for buttons and whatnot, and has an IPython kernel embedded. So we have an example called kapp, which is a very simple IPython kernel that manages, it's an object that manages an IPython kernel and does a few things with it. And this, you could imagine this being your GUI application, and the idea is you have a namespace. And you can actually open a Qt console pointed at your kernel. Your application could have, in this case, it has a namespace in which there's a variable called app counter. It's just an integer. Your application can, for example, has a button that increments the counter. Whenever you print it, it's there. App counter is 4. I can make it be 100. And if I increment it again, and now I print it, it's now 102, right? So the idea of this is now you have your own GUI application and there's some data in it. Well, as long as that data can be put into a namespace, you can bind that namespace to an IPython kernel, and whenever you turn it on, that application is listening with the protocols. Remember, there's this thing called connection info that tells you all of the connection data for that kernel, right? So you can, with this mechanism, basically give your arbitrary GUI codes a way for being connected to over the network and being controlled interactively, even if they're not living in a terminal, as long as they can talk over the 0MQ ports. And we have the Qt console client and the terminal clients that can attach to it. So this is one of the more slightly esoteric aspects of the system, right? But it can be potentially a very, very valuable one, okay? So this kind of concludes what we can do on this. I do have, at least I want to show you a flavor of what we can do with the parallel computing stuff, just so that you get a sense for how it feels, but we're not even going to have time to really do anything serious with it. Let me double check, because I know that Francesc is basically telling me, you need to stop talking. And
so I think it's worth to spare the 5 last minutes just to, if anybody wants to ask something, has some questions, perhaps more general questions than specific questions. Yes. Sorry. Let me give you the mic.
Are there still any Python 2 versus Python 3 issues with IPython?
No, IPython, the question got recorded. No, not really. IPython is fully Python 3 compatible. Our code base is Python 2 based, but upon install, if you run the installer, the setup PyInstall with Python 3, you'll get a Python 3 version. And on the Linux distributions, there's 3 versions of all of IPython, because our code is completely Python 3 compliant.
Okay, more questions? Okay.
Of the features that you guys have been talking about so far, what makes you the most proud?
That's a good question.
The architecture. It's the design. It's not any one feature. It's the fact that when we're in the notebook, we can talk to the same code in the back end with a text console, with a Qt console, that when we're doing parallel computing, we can connect and do the same interactive things that we can do. We can parallelize code that uses magic so that you can automatically do Cython in parallel that talks to local libraries. It's the cleanliness of the abstractions that I think we're, at least speaking for myself, because that's what has taken the most time. We've had for a long time a vision. For example, the parallel computing stuff is something that often people said, why don't you take it out? I just want to do parallel computing. I don't want the other stuff. And other people said, why do I have to carry parallel libraries around? I just want to do terminal stuff. And we always said, no, there's conceptually, those things have a unity where once you design, and it takes time to design that, but once you design the proper abstractions, the proper protocols, the proper way for all those things to interact, you gain enormous amounts of power. And there are things that we can do in 2 lines of code that are unthinkable in other environments. And that's because we have the right model of abstractions. And that has taken years to go from wouldn't it be neat to do this in principle to actually making a system where those abstractions are clean enough that they can interact in a way that functions and which doesn't just devolve into a gorpy, unmanageable mess. Yeah, you can call this and get plotting data in parallel from many engines with the same exact stuff that you do plots in one terminal, right? And bolting those things after the fact as a hack is effectively impossible. You just devolve into a complete nightmare. So I would say it's not one feature. It's the fact that this design enables features is, I think, what we're proud of.
Sorry. My quick question is, where do you see the future of IPython Notebook? Do you see it like currently that you recommend to run it on localhost because of all the security issues, or do you also want people to create like companies and host IPython Notebook with all the nice features that are implemented?
There's multiple already, right? Wakari has a hosted service. PyCloud has a hosted service. I just got an email from a company in Spain called iMath Research that I haven't even used it. They're a company from Barcelona, but they have, from the screenshots on the website, they have obviously what looks like a hosted IPython notebook. You can host it yourself in the cloud very easily with Star Cluster on Amazon or with Azure. So when Ming, unfortunately, because we ran out of time, we couldn't, but when Ming from Microsoft Azure had prepared a demo of how to very easily deploy hosted versions of IPython on the Azure cloud backend. We've been talking to some folks at Google about how to possibly deploy it easily on Google Compute Engine. So definitely there's going to be a lot of that. I still think there's value and a need for the local execution model. So we're not going to sacrifice one for the other. They serve different needs. But obviously that is a viable model and a very useful one. And I think people like Wakari a lot for that reason. So there's definitely, that's definitely one path. I should also say that part of the Sloan Foundation supported work is extending the current notebook to a multi-user server that you would run in sort of a trusted environment, not for arbitrary users in the cloud, 100,000 people, but say you want to deploy a server in a research group, in a class, in a university, in a place where you would already give people shell access. So if you have a multi-user server where you would already trust your users to have Unix access, then being able to say, I want to deploy a notebook server that has multi-user capabilities at that level, not so compartmentalized that you want to open it to random strangers on the net, but at that point, and that's what we're going to be working on next year, is extending the current design so that you can deploy it at kind of the class, group, university level.
So, okay, one more question.
And we're going to be here
That will be the last one.
For the whole week, so by all means catch us at breaks, at coffee, dinner, beers, etc.
What's the current state of the abstraction layer for the cells? If I want to add a new cell type, is that available?
New cell types, no. And that's a conversation we'd have to have kind of slowly and carefully and deliberately, because it's a tricky, it's not like, oh yeah, we know what to do, we just haven't done it. No, we want to think very carefully of what the answer should even be in the first place.
Yeah, and actually I would say at this point, so far we've made very deliberate choices to have that not be extensible.
Yeah.
We're open to discussing it further, but
and the main line of the conversation would be, what is it that you're trying to do, and could maybe that be done with a mechanism that has less of the potential problems of adding arbitrary cell types, and instead could we answer your question via the more generic metadata tools that we have. Right?
Okay, so thank you very much, Fernando and Brian, for an excellent tutorial.